the introduction class, I said that we have three forms. We have the rectangular form, we have the polar form, and we have the exponential form in the introduction class. So just get the video and watch it and get full details of what I'm talking about. But in this video, I'll be talking about the second form, that is a polar form of complex number. So this is another form of representation of a complex number. But in this case, in this type of representation, angle is involved. Okay, angle is involved. And a typical polar form is written as this: z is equal to r is into bracket cos theta, that means the argument, plus I sine theta. Okay, so that is the polar form representation. While our r, okay, is equal to x squared plus y squared. It's like the modulus of the complex number in rectangular form. So these are what we actually need basically. Z is equals to r cos theta plus I sine theta, where r itself is equals to root x squared plus y squared. Okay, this is what we're going to be using very quickly. I'm going to give you some examples. So let's check out an example. And we also know that from our argument class, we know that theta is equals to this y over x. This is not new. So you watch this video and get a full idea. So write the complex number. Suppose you're asked to write this complex number z, 3i 1 plus I in polar form. Suppose you're asked to write this in polar form. So what will you do? So first of all, what you want to do is you want to get the value of your theta and the value of your r. Once you can get these two straight, then you are good to go. So we're going to be putting in the idea of the argument we've learnt and the modulus we've learnt in the previous videos. Okay, so this one can be written as 3i plus, if I open the bracket, 3i squared. Alright, so this will be 3i minus 3, because I squared is minus 1. So that will be 3i minus 3. Okay, so if I want to, this will be my x and this will be my y. Don't forget. So for me to get my r now, my r will be the square root of 3 squared. Okay, then minus 3 squared. And that will definitely be 9 plus 9. And that is 18. Okay, if that will be 18, so my r will be 3 root 2. So note that my r is 3 root 2. My r is 3 root 2. So the next thing we want to find is the theta. How do we get to discover our theta? Our theta is arctan y over x. So in that case, theta now is equals to the arctan of what? Y. My y is 3, then over 3. I said in the class I should not add the negative, that the arctan diagram will decide the final answer. So this will be the arctan of 1, which is 45. So if I'm to represent this on an arctan diagram like this, this is on the x-axis I have minus 3 and I have 3. So it's actually on the second quadrant. Right? So in that case, if it's the second quadrant, we have 180 minus theta as the second quadrant. Therefore, my theta will be 180 minus 45. Okay, 5, and that is 135 degrees. So this is my degree and this is my r. So in that case, I'll put it together to satisfy this representation. Then that will be our final answer. Now will be is equals to, what's my r? My r is 3 root 2 into cos what? 135 degrees plus I sine 135 degrees. So this is how to actually represent complex number. This is how to actually represent it in polar form. Let's take one more example for clarification's sake. Let's take one more example. Z is equal to 2 plus 2i. You are asked to write this in polar form. The condition is theta is between 0 and pi over 2 rather. This is the condition here. So what you need to do is we want to satisfy this representation z r cos theta plus I sin theta. Okay, in that case my r is equal to 2 squared in that way and 2 squared. That will be 4 plus 4. Okay, that will be 4 plus 4, and that is 8. Root of 8 2 root 2 is my r. To get my theta, I will see that this is what the arctan of 2 over 2, that is y, this is y, and this is x. So I'll be having arctan of 1. Okay, it can be any number, it's not just 1, no. It's just depends on the question you are given. So this will be 45. Now on the Argand diagram, don't always forget it. After you must have gotten your answer, make sure you represent your rectangular form on the other diagram. So my 2 is here and positive y 2, there is 2 here. So I know that this is on the what, first quadrant, and the first quadrant we have just the theta, so there's nothing to change there. So my theta indeed is what, 45. To represent that in this form, without further ado, I will have z is equal to, what's my r? My r is 2 root 2 into cos of 45. So since my answer is given in terms of radian, 45 is also the same thing as writing pi over 4. So pi over 4, and this pi is actually in radian. So I have pi over 4 plus what, I sine pi over what, over 4. So this will be our final answer here. This will be our final answer for this one. So I hope it's actually very clear on how to do it now. So what you want to do is you want to find the value of your r and the value of your theta. Once you can get these two stuffs, you are good to go in getting the polar form of a complex number.